Hello coders, welcome to my channel. I am Aniket and today we will discuss problem 2 of lead code contest, that is frequency balance subarray. Let's read the problem. You are given an integer array nums. Define a frequency balance subarray as follows. If the subarray contains only one element, it is frequency balanced. Okay. If the subarray contains at least two elements, then every element with maximum frequency must occur exactly twice as many times every other distinct value in that array. Let's see this with an example. Let's say you have an array 3, 4, 5, and 6, 6. Here the maximum frequency is 2 because 6 are occurring 2 times and every other element occurring only one time. So if you compare the occurrence of the maximum frequency element to the all other elements, then it is a double. Maximum frequency must occur exactly twice as many times as every other distinct value in that subarray. So if you consider this subarray, then and you can you analyze that this 6 occurs two times, that is twice the every other occurrence of that element in the subarray. I hope you understand now what the condition is this. And if the subarray contains only one element, it is frequency balanced. Let's say the subarray contains 3, 3, 3, and 3 only. So this subarray is called a balanced frequency balanced subarray because there is no other element where you can compare. So you can uh, easily consider this subarray as frequency balanced subarray. So this is a frequency balanced subarray and this is also a frequency balanced subarray. I hope you understand what is frequency balanced subarray now. Now return an integer denoting the length of the longest frequency balanced subarray. You want to return the longest frequency balanced subarray out of all possible subarrays. And a subarray is a contiguous non-empty sequence of element with an array, it is obvious. And the frequency of an element x is the number of time it occurs in the array, it is also obvious. So now let's jump to the observation for this problem. The observation for this problem is there are only two types of frequency can be present in a subarray. How can I say that? Let's see it with an example. Here an example array is given and I question you, can you take this type of subarray? The answer to this question is no, you can't. You can't. Why? Because if you carefully see here, the number of frequency is 2 is repeating only one time, 4 is repeating two times, and 10 is repeating one time, and 1 is repeating four times. So here the if you calculate the number of distinct frequency, that is 1, 1, 2, and 4. So there are 1, 2, 4 frequencies. But you want to do here the you want to check this condition. Maximum frequency must occur exactly twice as many times as every other distinct value in that subarray. So let's consider this as the maximum frequency. So if you consider it with this 2, then it is good. But if you consider this 4 with this frequency 1, so it is not good. 1 into 2 is not is equal to 4. That's why it is not a frequency balanced subarray. I hope you got this because for comparison there should be only two types of frequencies present in the array, and if the frequency is 2, and then again you can check that the minimum frequency minimum and into 2 should be equal to maximum. In that case you will assign that a frequency balanced subarray. So there are two conditions. Frequency balanced subarray. First condition is there is only two size of frequency dot size should be 2 and minimum into 2 is equal to maximum. So these two conditions should always hold to make any subarray a frequency balanced subarray. Let's see this subarray, is this a frequency balanced subarray? So if you consider this, there is a two occurrence of 4, one occur 4 times and 10 occur 2 times and 4 occur 2 times here. So there are only two types of frequency, 2 and 4. And if you compare minimum into 2 is equal to maximum, and if you check this inequality, so 2 into 2 is equal to 4. So LHS is equal to RHS. That's why this subarray is a frequency balanced subarray. That's why the answer to this problem is 8, because the longest size that you can get as a frequency balance array is 8. I hope you now understand what the question is asking you and how can you find whether any subarray is frequency balanced or not. Now let's discuss the approach for this problem. The approach for this problem is very simple. First is generate all possible subarrays, and if that subarray is frequency balanced, then do answer is equal to maximum of answer comma j minus I plus 1. For generating all possible subarrays, the complexity is O of n square, uh, O of n square, and if that subarray is frequency balanced, then do answer equal to maximum of answer. So you will always maximize your answer whenever possible. J is the pointer of inner loop and I is the pointer of outer loop. In this way, you can easily maximize your answer and simply return that maximized answer as your answer. So in this question, there are two types of maps are used. In this question, there are two types of map. A normal map that will store the frequency of each element, a normal map, and the second is a frequency map. It will store the frequency of frequency. I hope you got this. How this will store, let's say here the frequency is uh, two frequency is 2 times and 4 frequency is 1 time, so it will the frequency map, and this is the normal map. And if the frequency map has a size of 2, then there is only two distinct frequencies in that subarray, and after that uh, you will check this condition minimum into 2 should be equal to maximum. If both of the condition are hold, then that subarray is considered as frequency balanced subarray, otherwise it is not. Let's discuss the code now. But before that, please hit the like and subscribe button so that you can't miss any future context explanations. I will consistently make such kind of intuitive video for you. So please hit the like and subscribe button. Let's discuss the code now. Here is my Java code where I initialize my answer to 0 and I will maximize my answer whenever possible. And n will stores the nums.length, and I will simply do a outer loop and inner loop to get the all possible subarrays. This is outer loop and this is inner loop. At every outer loop iteration, we initialize our fresh map and fresh frequency map. This map will store a normal map, which will store the frequency of any element. And this frequency map is the frequency of frequency map, which I has discussed earlier. And first we calculate the old frequency, that is when you not consider this element, then what is the frequency of that element. And now you calculate the new frequency. New frequency is simply old frequency plus 1. Simply you will update your map dot put is equal to nums j comma new frequency as classic map, because it is a normal map, so you can do it easily. And if the map dot size is equal to 1, it means only one element is present, so there is no comparison. One element is present, so there is no comparison, so you have to do answer is equal to map dot max of answer of j minus I plus 1, because there is no comparison. And in the question it states that if there is only one element, then it is also always considered as frequency balanced subarray. And if old frequency is greater than 0, it means nums of j is already present in the subarray. And if it is already present in the subarray, so you have to update your frequency map, that is old frequency, and it decreases its frequency by 1. If your old frequency is becoming 0, then you have to remove that old frequency key, and after that you will update your new frequency to frequency dot get or default of this method. This is a classic way to get a key value pair. Frequency dot put new frequency comma frequency dot get or default new frequency comma 0 plus 1. I hope you got this. And first of all, you will initialize your mini to integer dot max value and maxi to 0. And for each key, because there is at most two keys can be present in freq. So you will do key and find the min and max. If maximum is equal to 2 minimum, that is the first condition, and frequency dot size is also equal to 2, then you will maximize your answer equal to math dot max answer comma j minus I plus 1, and simply return your answer as your return statement. In this way, you can easily return your answer, which is denoting the maximum length of that subarray, which is a frequency balanced. So I hope you understand my code and the intuition behind this code. Please hit the like and subscribe button so that you can't miss any future explanation for any contest. Thank you for watching my video.